Hello students, welcome to the topic differentiability. As I said in last video, there are two important theorems in differential calculus. In that, one important theorem I discussed in my last video, that is Rolle's theorem. What is the statement and what are the conditions and some examples on that. So in this video, I'm going to discuss another important theorem, that is mean value theorem. Let me see what is the statement of this theorem. Mean value theorem states that let f from closed interval a comma b to r be real valued function. F is continuous on closed interval a comma b and differentiable on open interval a comma b, then there exists some point c belongs to open interval a comma b such that f dash of c is equal to f of b minus f of a divided by b minus a. That means if a function is continuous on closed interval a comma b and differentiable on open interval a comma b, then what happens? There exists a in between a and b, that is excluding end points. In between a and b there exists a one point c. The derivative value is given by always in this manner, that is f of b minus f of a divided by b minus a. This is the mean value theorem statement. Remember students, this theorem is also known as Lagrange's mean value theorem. So Lagrange's is a mathematician name. This theorem is known or famous as Lagrange's mean value theorem. Now see, what is the geometrical meaning of this f dash of c is equivalent to this f of b minus f of a divided by b minus a. What is the geometrically it means? That I'm going to discuss. Geometrical significance of mean value theorem. So consider coordinate axis, x-axis, x dash, y dash, and let me draw one curve. Y is equal to f of x and a point A on x-axis, and with respect to this A point, this is the point on the curve, that is f of a length, and this point coordinates are a comma f of a, and another point B on x-axis, and point on the curve is f of b, that is coordinates are b comma f of b. Now here we don't have any condition like in the Rolle's theorem f of a is should be equal to f of b. So this is the line called secant between the points a comma f of a and b comma f of b. So this slope of the secant is nothing but right side operation, that is f of b minus f of a divided by b minus a. So how you find the slope of this straight line, that is the slope of the between these 2 points? It is y2 minus y1 divided by x2 minus x1, that is nothing but right side operation, f of b minus f of a divided by b minus a. So geometrically that operation meaning is nothing but it is the slope of the secant. This line is called a secant between these 2 points. Next, C point. At this point, let me draw a tangent. Now, this slope of the tangent at C point denoted as f dash of C. Now, equivalent to that operation means slope of the tangent at C is equal to slope of this second line. So geometrically means that dash of c is equal to f of b minus f of a divided by b minus a. It is nothing but there exists a point c in between a and b such that the slope of the tangent at that point always equivalent to slope of the second between the points a comma f of a and b comma f of b. That is the geometrical meaning. So geometrically it means that there exists a point C in open interval a comma b such that slope of the tangent at C, that is f dash of C, is same as the slope of the second between a comma f of a and b comma f of b. That is this operation f of b minus f of a divided by b minus a. I hope you understood the geometrical meaning of that mean value theorem. Now see the important points. Remember the following points for mean value theorem. That means this theorem is applicable uh, if function is continuous in closed interval a comma b, and second point is f of x is differentiable in open interval a comma b. And another important point is if any one of these above condition fail, then mean value theorem does not satisfy. Now see the examples. First example, verify mean value theorem for the function f of x is equal to x square minus 4x minus 3. X is belongs to 1 comma 4. So this interval, closed interval 1 comma 4, it may be given as like a is equal to 1 number and b is equal to 4 number. Instead of x is belongs to 1 comma 4, they may give the interval 1 comma 4 as in this manner. Here a is equal to 1 and b equal to 4. Like that they give in the example. Now see the solution. First you take a given function f of x equal to x square minus 4x minus 3. Now let me discuss first the continuity and differentiability of this f of x. So this f of x is a polynomial function, so therefore it is continuous for all the real numbers. Therefore it is continuous in closed interval 1 comma 4, and also it is differentiable for all the real numbers. Therefore it is differentiable in the open interval 1 comma 4. Since given function f of x is polynomial function, first point f of x is continuous in closed interval 1 comma 4, and second point is f of x is differentiable in 1 comma 4. So writing these 2 points is very important, students, in examination. Now next you find out the function values f of a and f of b. So the first is f of 1. So in this f of x function, substitute x is 1, that is 1 square minus 4 into 1 minus 3. Simplify this, it become 1 minus 4 minus 3. So that is minus 6, and denote this as a f of a. So in the same way, second point, that is f of b. F of 4 is equal to, substitute x is equal to, in this function, x equal to 4. 4 square minus 4 into 4 minus 3. Here 16 minus 16 minus 3. 16 minus 16 get cancelled. That means it becomes 0 and you will get minus 3. So take this as a f of b. So here no condition that f of a and f of b are equal. Okay, if they are equal, then it theorem is nothing but Rolle's theorem. Okay. Now let me find f dash of x, because f dash of c is required. So now f of x is equal to x square minus 4x minus 3. Find derivative of this, that is f dash of x. x square derivative is 2x minus 4x derivative is 4 constant, x derivative is 1, 4, and 3 is a constant 0 value. By mean value theorem, so this is the mean value theorem formula, f dash of c is equal to f of b minus f of a divided by b minus a, and f of b value is this, f of a value is this. F dash of c is equal to f of b is minus 3 minus f of a, that is minus 6, divided by b minus a, that is 4 minus 1. So in the next step, substitute f dash of c means f dash of x, in that take x equal to c, equal to, simplify this, minus 3 plus 6 divided by 3, and 2c minus 4 is equal to 3 divided by 3, so it will get cancelled. So we will get 2c minus 4 equal to 1. So transfer minus 4 right side, it become plus. So 2c is equal to 1 plus 4. So next 2c is equal to 5. Transfer 2 right side, you will get c is equal to 5 by 2. So this is the c point. That is, this c point is belongs to open interval 1 comma 4, because 5 by 2 means 2.5. So definitely this 2.5 number belongs to in the open interval 1 comma 4. What you have to understand here, at this point, if you draw a tangent, this tangent slope is equivalent to slope of the secant between the points. Now see the next question. Verify mean value theorem for the function f of x equal to x cube minus 5x square minus 3x, and x is belongs to 1 comma 3. First take given function f of x equal to x cube minus 5x square minus 3x. So again it is a polynomial function, so easily we can discuss what is the continuity and differentiability of this function. So since given function is a polynomial function, f of x is continuous in closed interval 1 comma 3, and f of x is differentiable in open interval 1 comma 3. And next is finding the function value, that is f of 1. So in this f of x, put x is equal to 1. 1 cube minus 5 into 1 square minus 3 into 1. That is 1 minus 5 minus 3. Then f of 1 is equal to minus 7. And denote this as a f of a. So in the same way, operate f of 3 is equal to 3 cube minus 5 into 3 square minus 3 into 3. So this become 27 minus 5 as it is, 3 square is 9, minus 3 into 3 is 9. In the next step, 27 minus 9 into 5, 45, minus 9. And this you will get f of 3 equal to minus 27. And denote this as a f of b. So in the next step, find the f dash function. First you write f of x, that is x cube minus 5x square minus 3x. Differentiate with respect to x, we get f dash of x is equal to 3x square minus 5 into 2x minus 3 into 1, that is 3. So simplifying this, you will get a 3x square minus 10x minus 3. So this is f dash of x function. Now by mean value theorem, so this is the theorem formula. Okay. Next is f dash of c is equal to f of b is minus 27 minus f of a is minus 7 divided by b minus a, that is 3 minus 1. Next, substitute f dash of c, that is in this f dash of x, put x equal to c. 3c square minus 10c minus 3 equal to, and simplify this, you will get a minus 27 plus 7 divided by 2. So left side as it is, 3c square minus 10c minus 3 is equal to, so this is minus 20 divided by 2. So here it is cancelled, 2 ones are 2 tens are. So next you will get a 3c square minus 10c minus 3 is equal to minus 10. So transfer this minus 10 left side. So you will get 3c square minus 10c minus 3. So it becomes plus 10 equal to 0. So operating that minus 3 and 10, you will get 3c square minus 10c plus 7 is equal to 0. Now we have a quadratic equation in terms of c. So find the c value solving this quadratic equation. So here we have to find out the factors. Adding minus 10, multiplying, you should get a 21. So now therefore 3c square, and this minus 10c is written as minus 3c minus 7c. These are the two numbers which satisfies that condition. Adding, you will get minus 10, multiplying, you will get a plus 21. So plus 7 as it is equal to 0. Now from this 3c we can take common, c minus 1, and in the second term, in this 2, we can take minus 7 common, you will get a c minus 1 is equal to 0. From this you will get a c minus 1 into 3c minus 7 is equal to 0. So this implies c minus 1 equal to 0 or 3c minus 7 equal to 0. So from this you will get c equal to 1, but this number is not belongs to open interval 1 comma 3. You know that in the open interval 1 comma 3, this one is not belongs to the set. Therefore this one is not belongs to 1 comma 3, open interval 1 comma 3. Okay, now from the second one, c point, you will get 7 by 3, and this value is nearly 2 point something, and this number belongs to open interval 1 comma 3. So this is the point exists between 1 comma 3. Now see the next question. Verify mean value theorem for the function f of x is equal to x square. X is belongs to closed interval 2 comma 4. So first take given function f of x equal to x square. Since given function is polynomial, x square is also polynomial function. F of x is continuous in closed interval 2 comma 4, and f of x is differentiable in open interval 2 comma 4. And find out the function values f of 2. So easily you can operate here 2 square. So that is f of 2 equal to 4, and denote this as a f of a. Similarly f of 4, that is 4 square, it is 16. Denote this as f of b. Next find out derivative. F of x equal to x square, f dash of x is equal to 2x. Now by mean value theorem, so this is the theorem formula, and here f of b is 16 and f of a is 4. So f dash of c is equal to f of b, that is 16 minus f of a 4 divided by b minus a, that is 4 minus 2. F dash of c means 2c is equal to, operating this, you will get a 12 divided by 2, and this is cancelled, 2 ones are 2 6 are, so you will get 2c is equal to 6. So therefore 2 transfer right side, you will get c is equal to 6 divided by 2, that is 2 ones are 2 3s are cancelled, you will get c is equal to 3. So this number 3 is belongs to the open interval 2 comma 4. Now see the next example. Examine the mean value theorem for the function f of x equal to greatest integer x, and x is belongs to 5 comma 9. Given function is f of x equal to greatest integer function. So as you know that already we discussed about this function in the Rolle's theorem in the same interval, whether Rolle's theorem satisfy or not. Now here we are discussing whether mean value theorem satisfy or not. So according to the conditions, so function should be continuous in the given interval. Here clearly greatest integer function is not continuous in this interval, because in this interval we have integers like 5, 6, 7, 8, 9, and it is not continuous at integer points. We know that greatest integer function is discontinuous, that is not continuous at all the integer points. So here given function f of x equal to greatest integer function and x is belongs to closed interval 5 comma 9 is discontinuous at the points 5, 6, 7, 8 and 9. So therefore mean value theorem fails here. So next example, examine the mean value theorem for the function f of x equal to mod x, and x is belongs to closed interval minus 1 comma 1. So here also we discuss continuity and differentiability. First you write a function. So here this function is continuous for all the real numbers, but it is not differentiable at 0 point, and that 0 point is belongs to open interval minus 1 comma 1. So therefore what we can say, this mod x function is not differentiable in the open interval minus 1 comma 1. So first let me write about the continuity. We know that modulus function is continuous for all the real numbers. Therefore f of x equal to mod x is continuous in closed interval minus 1 comma 1. But f of x is equal to mod x is not differentiable at 0, and 0 is belongs to open interval minus 1 comma 1. So therefore mod x is not differentiable in open interval minus 1 comma 1. So therefore what we can say here, mean value theorem fails. Next example, examine the mean value theorem for the function f of x equal to x square minus 1. X is belongs to closed interval 1 comma 2. F of x, first you take given function f of x equal to x square minus 1. Since given function is polynomial function, so first point, f of x is continuous in closed interval 1 comma 2, and second point is differentiable in open interval 1 comma 2. Then next you find f of 1 square minus 1, that is 0 value, and denote this as a f of a. In the same way operate f of 2 square minus 1, that is 4 minus 1, it is 3. So denote this as a f of b. So in next step find out the derivative of this f of x. So first write f of x, x square minus 1, differentiate with respect to x, you will get f dash of x equal to 2x and 1 is a 0. By mean value theorem f dash of c is given by f of b minus f of a divided by b minus a, and in this example f of b means 3, f of a is 0. So therefore f dash of c is equal to f of b 3 minus f of a 0 divided by b minus a, that is 2 minus 1. So left side substitute f dash of c term, that is f dash of x, replace x by c. So you will get 2c is equal to 3 minus 0 is 3 divided by 2 minus 1 is 1. So you will get a 2c is equal to 3 upon 1 means it is 3. So transfer to right side, you will get c is equal to 3 by 2. And this number is belongs to open interval 1 comma 2 because 3 by 2 is nothing but 1.5, so which is belongs to the open interval 1 comma 2. That means the given function satisfy mean value theorem. That means we get a point in between open interval 1 comma 2. I hope you understood mean value theorem and the examples on that, students. Thank you, students.